Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra, the Math 8 edition. I'm your host, Mr. Takeda, and I'm going to teach you some math right now. This is lesson 3.4 on similar triangles, so get ready and let's go. First big idea, similar triangles. So we have this word similar. Now in real life, in actual real world things, you probably are familiar with the word similar, meaning that things are kind of alike. But in math, it has a specific definition. And let's talk about what it means for two triangles to be similar. And when two triangles are similar, that means all the angles are the same. So in the smaller triangle, you can see we have angles of 65, 95, and 20. In the larger triangle, the angles are also 65, 95, and 20. The side lengths are different, but the angles are the same. So we consider these triangles similar. Now, one thing that we also know is that since the sum of the interior angles of a triangle have to equal 180, if two angles are the same, the third one must also match, right? The third one must also be the same. Okay, so let's look at an example and put this idea into use here. And we want to tell whether these triangles are similar. So in triangle A, I have a 75-degree angle, and in the larger triangle, I have a 75-degree triangle. I said triangle A. This is example A, sorry. In the smaller triangle, I have a 75-degree angle, and the larger triangle, a 75-degree angle. In the smaller triangle, I have a 50-degree triangle, and in the larger one, also a 50-degree. That means that X and Y have to be the same, so these are similar. In other words, 50 and 75 would be 125, and that would make angle X 55 degrees. That would also make angle Y 55 degrees. So these are similar. All the angles, it says explain, all the angles are the same. In this example, what do we have? Now this one is a little trickier. Look at this one. 54 and 63. This one is 63 and 63. But couldn't this one be 63 and this one be 54? Let's find out here. So in the larger triangle here, I'm going to add together 54 plus 63 plus X to equal 180. And then I'll add these together. 4 and 3 is 7. 5 and 6 is 11. So I have 117 plus X equals 180. So subtracting 117 from both sides, X will equal 180 minus 117, 63. All right. So this one is 63. So now I have two 63s, which means this Y has to be the 54. So these are similar. And we have one last example we want to look at here. So what do we have here? I've got two triangles. Now they don't look similar, but let's take a look at what we have here. We have a 90-degree angle here and a 42-degree angle here. Here I have 90 and 38. So the question is, let's solve for this one. Let's solve for X and see if it comes up to be 38. Okay, so 90 plus 42 plus X equals 180. So 132 plus X equals 180. And then subtracting 132 from both sides, X equals 180 minus 132 is 48. So if this is 48 and this is 38, these cannot be similar, not similar. And again, they do not have matching angles. All right, so you got to be careful on these. You just can't look at it and guess. You have to do some calculations to find out some more information sometimes. All right, so let's take a look at the next idea. The next idea here is indirect measurement right here. And it uses similar figures to find a missing measure when it is difficult to find directly. In other words, we measure what we can, and then because we know we have similar figures, we can calculate the missing figure that we can't measure directly. All right, so what do we have here? You plan to cross a river and want to know how far it is to the other side. Okay, so you're trying to cross this river here. You take measurements on your side of the river, so it looks like we're over here. Here he is. That's you. And make the drawing shown. Explain why A, B, and C and D, E, C are similar. What is the distance x across the river? Well, these will be similar. Why are these similar? Because they both have a 90-degree angle. And they share this vertical angle here. Remember what we said about vertical angles? Vertical angles share this vertex where two lines cross, and they're going to be congruent, right? Vertical angles. So those are going to be equal. I'm going to say congruent. I'm going to use the math language here. Okay, so I've got two angles the same. That means this third angle, this angle A and angle D, must also be the same. So these are going to be congruent. So then we're asked, what is the distance x across the river? So we're trying to find this distance here. Okay, so what we know is that from B to A it's 60 feet, and x is the corresponding side to that distance over here. It's the distance from the right angle to that missing angle, right? So x is the distance from the right angle to the missing angle over here. So how are we going to do this? We are going to set up a proportion between things that we know. So in this case, the 40-foot distance here and the 50-foot distance here are corresponding sides, and they're going to be in proportion. All right, so here's what we're going to do. I'm going to write 40 over 50, and that's going to be equal to, now 40 is the on the smaller triangle, 50 is on the larger triangle. For the unknown, that's going to go above, and then the corresponding side goes below. All right, so these two sides are the same corresponding sides. These are corresponding sides as well. So we're going to solve this by cross multiplying. 40 times 60 would be 2400, and then 50 times x is 50x. So I'm going to divide everything by 50. Those across there. And let's see, that's going to be 240 divided by 5, or I'm essentially taking the zeros off of here because they'll cancel out. So 240 divided by 5, 48. So what is the distance x across the river? 48 feet. Okay, that's it. That's a good example of using indirect measurement and proportions to find a missing measurement. All right, that's it. Thanks a lot, and I'll see you in class. Bye-bye.